Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on electricity from May-June 2021, paper 2-1. For part A, we need to state Kirchhoff's second law. Kirchhoff's second law simply tells us sum of EMFs. EMFs means if we have more than one electrical source in the circuit, that has to be equal to sum of potential difference, or simply we can say sum of TDs in a closed circuit. So we also need to mention in a closed circuit, we can say in a closed circuit, or we can say in a closed loop. In a closed circuit, or you can also say in a loop. Now this question has 2 marks. The first mark is for this part. If you have written sum of EMFs is equal to sum of PDs, you will get 1 mark. And this is M mark, means it must be in the answer. And the second mark is answer mark. So this is second mark. But if you cannot get M mark, you will also not get A mark. So M mark is must mark, means it must be in your answer. And the A mark is depending on M mark. If you can't get M mark, you will also lose A mark. Let's try to understand Kirchhoff's second law with the help of one simple circuit. So let me draw one circuit here first of all. If you look at this one very simple circuit, let's say the EMF of this cell is E and this resistor is R1. If we connect voltmeter across this one, let's say the reading on this voltmeter is V1. And this is the potential difference across this resistor. And now if we look at this closed loop, in this case simply we can say the EMF is equal to the potential difference across the resistor. So this is our closed loop. So simply we can say in a closed loop, in this case, in a closed loop, or we can say in a closed circuit, EMF is equal to V1. Means the EMF is equal to potential difference. We can also extend this idea to 2 resistors. Now let's connect 2 resistors across this cell. So this is our resistor 1, and here let's say we have another resistor. We can say this is R2 and this is R3. If we connect voltmeters across these resistors, and let's say the reading on this voltmeter is V2, and this is telling us the potential difference across second resistor. And we connect another voltmeter, and that one is across third resistor. Now if you look at this closed loop, means if we start from here and we form a closed loop. So this is our closed loop. Now if you look at this closed loop, we can also say that in this case EMF is equal to V1 plus V2. If we have more than one power source, then we will say E1 plus E2. Let's say we have 2 power sources. In this case, I can also connect another source here. Let's say this is another cell that is connected here. So this is E1 and this is E2. And so the EMF of this cell and the second cell, we will say in this case V1 plus V2. So simply we can say the sum of EMFs in any closed loop, sum of EMF is equal to sum of PDs, and this is Kirchhoff's second, and this is how you need to state. For part B, it is given to us the wire XY, means this wire XY. The resistance of this wire is given. Simply we can say the resistance of this wire is 0.90 ohm. So this is resistance of this wire. It is also given to us the potential difference across XY. This is equal to 1.8 volts. This simply means if we connect voltmeter across this wire, means between X and Y, the reading on this voltmeter, this is equal to 1.8 volts. Now question is asking us, we need to find out how much current is passing through this wire. So very straightforward one. Simply we need to use Ohm's law. We will say V is equal to IR. V is the potential difference across the wire. So simply by using Ohm's law, we can find I. From here we can say I will be equal to V over R. V is the potential difference across the wire. R is the resistance of the wire. So the potential difference across wire is 1.8 volts. We need to divide by the resistance of the wire, that is 0.90 ohms. So our final answer in this case will be 2.0 amps. And this is the final answer. This question has only 1 mark. If you have got the right answer, you will get this 1 mark. So simply we can say up to 2 SF, this is 2.0 amps. For part B, we need to calculate the number of free electrons that pass a point in the battery in a time of 45 seconds. First thing we need to understand, the current leaving this battery is I and current entering this battery is also I. And value of I we have already calculated, that was equal to 2.0 amps. Time is given to us, time in this case is equal to 45 seconds. So T is equal to 45 seconds. We need to find out number of electrons. So we can start from here. Q is equal to IT. But we need to find the number of electrons. So Q we can write down. Q will be equal to N times E. N is the number of free electrons and E is the charge on single electron. So we can say NE, this is equal to IT. We need to find out value of N. So simply we can rearrange. We can say N is equal to IT divided by E, and E is the charge on single electron. I is given to us, this is equal to 2, and the time is given, this is 45 seconds. And the charge on single electron is 1.6 times 10 to negative 19 coulombs. If we simplify this one, our final answer will be 5.6 times 10 to 20. And this is the number of electrons. And this is the number of electrons passing through a point in 45 seconds. So our final answer is 5.6 times 10 to 20. This question has 2 marks. The first mark is if we have written Q is equal to IT. So this is C mark. We will get 1 mark. And the second mark is answer mark. And this is for the right answer. If you have got right answer, you will get 2 marks. For this part, we need to calculate the resistance of capital R. Simply, we need to find what is value of this capital R. For this purpose, we simply need to use Kirchhoff's second law. According to Kirchhoff's second law, in any closed loop, as we have discussed in part A, in any closed loop or circuit, sum of EMFs simply we can say sum of EMFs has to be equal to sum of PDs, potential difference. If we look at this closed loop now, we can first draw this loop. This is just one loop, so let's redraw this one loop. In this loop, we only see one EMF, and that is 4.0 volts. Now, if we go across this wire, for this wire, potential difference across this wire is given in the question, and the value of that is 1.8 volts. So we can simply write down here, or we can simply say VXY, potential difference across this wire, plus the potential difference across capital R resistor, and we can say this resistor is small r because this is internal resistance. We can denote this one with small r. So this is I times R. Now simply we need to plug in values. So we have 4.0 and VXY, it is given in the question, and that is equal to 1.8 volts. I in the question we have, this is 2 amps and this is the capital R, the resistance. I also the same passing through this internal resistance, so this is also true. And the value of R we have, that is 0.35 ohms. Now if we simplify for R, our final answer for R will be 0.75 ohms, and this is our final answer. So this is 0.75 ohms. In the first mark you will get if you have written this one. So this mark will be C1. And the second mark you will get if you have got the right answer. Simply speaking, if you got the right answer, you will get 2 marks for this question. For part C, we need to calculate total length L of wire XY. But for this question, it is given to us the connection P is moved along the wire XY. It simply means that we started moving our slider from this point and we keep on moving this one until it is at point P. Now it is given to us the galvanometer reading is 0 when the distance XP is 0.30 meters. Means the distance between X and P when this is equal to 0.30 meter. The reading, if we connect voltmeter across XP, means between X and P, the reading on this voltmeter is equal to 1.20 volts because this galvanometer reading is equal to 0. So this is what question is telling us. What we need to do is we need to find the total length of wire XY. But in the previous part, we have already calculated the potential difference across XY. Means simply if we connect voltmeter between X and Y, the reading on this voltmeter is 1.8 volts. We have already calculated in the previous part. In order to answer this question, you need to understand the ratio between Vxp and Vxy is equal to the ratio between Lxp and Lxy. But for this question, it is given to us that Lxy, this is equal to L. So simply we can say Lxy is equal to L. Now we need to find out value of L. So simply we can say in this case, L will be equal to Vxy multiplied with Lxp divided by Vxp. Vxy we have that is equal to 1.8 volts. We need to multiply with Lxp. Lxp is 0.30 meters. We need to divide by Vxp, and the Vxp is 1.2. So this is 1.2. If we solve this one, our final answer will be 0.45 meters. So this is the final answer. This question has 2 marks. The first mark is if you have written in this form, means if you have written the ratio between Vxp and Vxy and the ratio between Lxp and Lxy, these are equal, you will get 1 mark. So this is C mark. And the second mark is answer mark. This is for the answer. If you got right answer, you will get 2 marks. Let's try to understand a little bit more about potentiometer and especially about this relationship, mean how we got this one. So let me explain you this part. Simply we can say that Vxp, this is equal to I times R. Here we are talking about Xp part of the wire. We can say current in that part and resistance of that part. We can also write down Vxp is equal to Ixp times the resistance. That we understand resistance is equal to resistance of any wire. This is equal to rho L by A. So we can write down here, this is rho and A is the cross-sectional area of the wire. We can say this is AXP. And we can simply write down VXP. In this case, this is equal to IXP times rho times LXP, and this is divided by AXP. So this is how we can write down VXP. We can also follow the same procedure for VXY. For VXY, we can say this is equal to IXY times resistance of wire XY. I is the current passing through wire XY. So we can write down this IXY. Resistance we can write down, this is resistivity times length of the wire XY divided by the cross-sectional area of the wire. So we can say this is AXY. So this is VXY. Now we need to understand for these two wires, what is the same? For the same wire, now we can say for same wire, because in this question we are talking about this wire and this is the same wire. Simply this is the same wire. We are talking about this same wire, and for this same wire, now we need to understand what is same for XP and for XY. The first thing we can say that in this case IXP, this will be equal to IXY, or simply we can say this is equal to I. Second, we need to understand AXY, because the same wire and the cross-sectional area of the wire is uniform. So we can say AXP, this will be equal to AXY, or simply we can say this is equal to A. Rho is also the same because we are talking about the same wire. So it means rho XP, this is equal to rho XY, and we can simply say this is equal to rho. Now simply we need to divide. So we can write down VXP. If we divide VXP by VXY, we can also say this is equation 1 and this is second. So we can say 1 divided by 2 means it equation 1 divided by 2. So we can write down these things here. So here we got I, and this is rho, and this is LXP. So this is LXP, and this is divided by A. AXP is equal to A. And we need to multiply this one with A divided by I times rho, and this is LXY. Now from here, simply we need to cancel. So you can see I is here. We can cancel with I. Rho we can cancel with rho. A we can cancel with A. So we left with Vxp over Vxy. This is equal to Lxp divided by Lxy. That's the reason we wrote ratio between Vxp and Vxy is equal to ratio between Lxp and Lxy. So this is how you can derive this one. So simply let me write down again here. So we will get Vxp divided by Vxy. This will be equal to Lxp divided by Lxy. Means the ratio between potential difference is equal to ratio between L. For the second part, it is given to us the fixed resistor is replaced by a different fixed resistor of resistance greater than capital R. We need to state and explain the change, if any, that must be made to the position of P on wire XY so that the galvanometer reading is again 0. We can divide this question into two parts. First thing we need to understand, when the resistance of this resistor is increased, what is the effect of this one on the potential difference between X and Y, means on the reading of this voltmeter. So if this resistance increase, the potential difference across XY, it will go down. So this is the first thing we need to understand. The potential difference across XY, this will go down. We also need to understand that the ratio between Vxp and Vxy, this is equal to Lxp by Lxy. From here we can write down Lxp, this will be equal to Vxp times Lxy, and this is divided by Vxy. But if you look at this question, it is given to us that Vxp is not changing. We want the same Vxp. Mean this one is not changing. Lxy, the length of the wire, this is also not changing. But Vxy has decreased. So if this has decreased, so Lxp has to increase. This is how you can write down your answer. So we have simply mentioned PD across XY decreases, as we have discussed here. PD across XY decreases. So if you have written this one, you will get 1 mark, and this is B1 mark, means it has to be in your answer. The second mark you will get if you have written P is move towards Y, mean this P you have to move to the Y, or simply you can say to the right. So you will get the second mark, and second mark is also B mark. It has to be in your answer. Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's class, we will discuss questions on electricity and radioactivity from Cambridge AS Physics, Paper 2, March 2021. Part A is asking us to state Kirchhoff's first law. And this is very common question in past papers. Sometimes in exam they will ask you to state Kirchhoff's first law. Sometimes they will ask you to state Kirchhoff's second law. So you need to be very clear about these two laws. Let's try to understand what exactly Kirchhoff's first law is. We can understand this one simply with one very simple circuit. As you can see here, I have drawn this circuit now. Let's say the EMF of power supply, this is V0, and this resistor is R1, and the second resistor is R2. And also, let's assume that current coming from the battery in this circuit is I0, and current passing through resistor 1, this is I1, and current passing through second resistor, this is I2. Now according to Kirchhoff's first law, at any junction, let's say if we study this junction, if we look at this junction, according to Kirchhoff's first law, I entering has to be equal to I leaving. I entering has to be equal to I leaving. Means the total I entering has to be equal to total I leaving. In this case, current entering this junction is I0 and current leaving this junction is I1 and I2. So this is simply Kirchhoff's first law. Let me explain to you how you can write a proper answer. This is how you can write your answer for Kickoff's first law. Simply you can say at a junction the total current entering the junction is equal to total current leaving the junction. For part B, circuit is given to us. As you can see, it is given in figure 6.1. In this circuit, we have a power supply. So this is battery, or simply you can say this is power supply. So this is over battery. And this battery has internal resistance and EMF of this power supply is 12 volts. Total current coming from the battery, that is also given, that is 3.6. One lamp is connected here. You can see this is lamp. So this is symbol for lamp, and resistor is connected here and current passing through resistor, this is also given. This is 2.1. But in figure 6.2, you can see the IV characteristics curve for the lamp is given. Means we have graph between I and V for the lamp. And part B1 is asking us to calculate the resistance of the lamp in figure 6.1. This is figure 6.1. The resistance of this lamp is not given, and we can find current passing through this resistor. So this is 2.1. So current passing through resistor, this will be 1.5, because the total current means the I total. This is equal to I means current passing through lamp plus this is I passing through resistor. So if we need to find I lamp, so this is simply equal to I total minus IR. In this case, I total is 3.6 minus we have 2.1. So current passing through this lamp, this is equal to 1.5 amps. Now the current is given for this lamp, means the current passing through this lamp is given. So we can find out the voltage across this lamp, and the voltage we need to look at IV characteristics curve. So this is I, and on x-axis we have V. So when current is 1.5, you can look at this point, value of V is 4.4. So this is value of V. Now we have the potential difference across this lamp, and we have current passing through this lamp. So R we can simply calculate by V over I. Means simply we can use Ohm's law. So this is 4.4 divided by I, and I is 1.5. If we solve this one, our final answer will be 2.9 ohm. So this is our final answer. So we can write down here our final answer is 2.9. Second part is asking us to calculate internal resistance R of the battery. Means we need to find the value of this resistance. For this one, we can take this loop. We can consider this loop, and we can use Kirchhoff's second law. So in this case, one thing we need to understand is that EMF of power supply, this will be equal to the voltage across lamp, means the potential difference across lamp plus potential difference across this resistor, internal resistance R. So simply we can write down EMF is to 12.0, and potential difference across lamp we have just found. When current is 1.5, potential difference is 4.4, and current passing through this resistor, that is equal to 3.6 times R. So from here we can find value of internal resistance. So if we do calculation, internal resistance will be equal to 2.1 ohms. So this is value of internal resistance. For third part, question is simply asking us that the initial energy stored in the battery is this, and EMF, we need to assume that EMF of power supply and current in the battery do not change with time. We need to calculate the time taken for the energy stored in the battery to become 240 kilojoules. Or we can simply draw like this. Question is simply asking you the initial energy of power supply. If this one, we can say this is EI, initial energy, and then it decreases to 240 kilojoules. We can say this is final energy. So this is the final, and question is simply asking us what is the time taken. Means we need to find out what is value of delta T. So for this purpose, we can simply say delta E in this case has to be equal to EMF of power supply times current passing through power supply multiplied by delta T. So simply we need to find the change in energy. So how we can find the change in energy? In this case, we can simply subtract 240 from 470. We can write down 470 minus 240, and we need to multiply with 10 to 3. And EMF of power supply is given, that is 12, and current passing through the power supply, that is also given, that is 3.6, and we simply need to find delta T. If we solve this one for delta T, our final answer will be 3935 seconds. We can write down this answer up to 2SF. So simply we can say 3900 up to 2SF. So our final answer is 3900 seconds. Otherwise, we can write down in standard form. We can say this is 3.9 times 10 to 3 seconds. And this is our answer. For the last part, it is given to us that filament wire and copper wire, they are connected in series, and the cross-sectional areas and number densities are given. Question is asking us to calculate the ratio between average drift speed of free electrons in filament wire to average drift speed of free electrons in copper wire. So this is kind of typical question on transport equation, and this is our transport equation. Means I is equal to NQV. So we need to understand what is Q here. Q is the charge on single electron, and its value is constant. This is 1.6 times 10 to negative 19 coulombs. First of all, let's try to draw one very simple table to write down the given data for filament wire. So this side, let's say, is filament wire, and here we will write down data for copper wire. So in this case, current is the same, means current passing through filament wire, and copper wire is the same because they are just connected in series. We can simply say I is the same, but Q is also the same because this is a constant. So these two quantities are constant. So simply we can rearrange this equation, and we can write down that I over Q, this is equal to N times VA. N times VA, and this ratio between I and Q, this is constant for these two wires, is constant. So simply we can write down the number density of filament wire and drift speed of free electrons in filament wire times its cross-sectional area. This is equal to number of free electrons in copper wire times average drift speed of free electrons in copper wires. So C for copper times cross-sectional area of copper wire. But question is asking you the ratio between drift speed in filament wire over drift speed of free electrons in copper wire. So we just rearrange this, then we can say this is NC AC divided by this is NF times AF, and the values of NC means number density for copper wire is given, that is 2.5 N, and cross-sectional area of copper wire is given, that is 360 times area of filament wire, cross-sectional area of filament wire. And number density for filament wire is given, that is simply N, and cross-sectional area of filament wire is given A. Now simply we can cancel A with A and we can cancel with N. If we just multiply these two, our final answer will be 900. So it means the ratio between drift speed of filament wire and drift speed of free electrons in copper wire, this is equal to 900. So this is our final answer. You can also understand like this: the speed of free electrons in filament wire is 900 times greater than speed of free electrons in copper wire. Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on electricity from October-November 2021, Paper 2, Variant 1. This is a typical type of question because this type of questions are very common in past papers. For part A, simply we need to state what is Kirchhoff First Law. Kirchhoff First Law, Kirchhoff Second Law, these are very common type of questions you will see in many past papers. Sometimes they will ask you to state what is Kirchhoff First Law. Sometimes they will ask you to state what is Kirchhoff Second Law. So you have to be very clear about these two laws. Now let's try to understand what is Kirchhoff First Law. Kirchhoff First Law simply we can understand with one very simple circuit. So let me draw one simple circuit here. Let's say we have the circuit, and in the circuit we have one battery, or simply you can say one cell and two resistors that are connected in parallel. Kirchhoff First Law simply tells us, let's say current coming from the battery is I at this junction. This point is called junction, or you can say this is node. So current will split into two parts. Let's say current I1 go through this resistor. Let's say this is resistor 1 and this is resistor 2. And current I2, this will go through the second resistor. Now Kirchhoff First Law simply tells us that current entering means I entering. This junction has to be equal to I leaving. So simply we can say I entering, this has to be equal to I leaving. I entering in this case, this is equal to I, and I leaving, this is equal to I1 and I2, means I1 plus I2. And this is what Kirchhoff First Law tells us. So simply this is what you need to understand. Now we need to understand how we can write down our answer. In order to write down the answer, simply you can say at any junction, simply you can say at any junction. So this is one point you have to mention: at any junction in a circuit. We can say in a circuit I entering has to be equal to I leaving. That's all what you need to write down. I entering has to be equal to I leaving. So if you write down these 2 points, you will get 2 marks. But for this question, I entering is equal to I leaving, this has to be in your answer because this has M mark. So if you write down this one, you will get this mark. And the second mark is for this one, and this is A mark. So you must get M mark to get A mark. So it has to be in your answer. If you didn't write this one, if you mention this part, still you will not get any mark. Now let's try to write down complete answer. This is how you can write down a full answer for this question in a proper way. So this is at any junction in a circuit. So this has 1 mark, this is A mark, and the second mark is M mark. So if you write down sum of currents entering is equal to sum of currents leaving, so you will get M mark, and this is A mark. You must get M mark to get A mark. If you can't get this mark, even you have written this part, still you will get 0 marks. So this is very important. For part B, it is given to us the circuit shown in figure 5.1. It contains a battery of electromotive force capital E and negligible internal resistance, means internal resistance of this battery, this is equal to 0. We can assume this is equal to 0. And it is also given to us there are 4 resistors, and all these resistors, they have the same resistance. So it simply tells us that all the resistors in this circuit, they are identical resistors. So simply we can write down all the resistors are identical resistors because they have the same resistance. Now let's say current I1 is coming from the battery and this current will pass through this resistor. And let's say current I2, this is passing through the second resistor, and current I3, this is passing through this resistor. And current I4 is passing through resistor 4. We can simply say this is I4. And this is the current entering the battery as well. Now let's connect voltmeter across this second resistor. So we can connect our voltmeter here between these 2 points. We can also connect another voltmeter across this resistor. Let's say this is another voltmeter and this is connected between these 2 points. Now we need to understand, as this is connected at this point, so the potential at this point and potential at this point is the same, because there is just ideal wire between these 2 points. There is no any other circuit component connected here. So this point, they are at the same potential. If we look at these 2 points, this point, they are also at the same potential because there is just ideal wire, and ideal wire has no resistance. So if the reading of this voltmeter is V2 and the reading of this voltmeter is V3, so simply we can say in this case V2 will be equal to V3. V2 we can also write down, V2 is equal to I2 times R, because R2 is equal to R and R3 this is also equal to R as it is given in this question. We can also write down V3, this will be equal to I3 times R. Now R is common on both sides, we can simply cancel. We can say I2, this will be equal to I3, and I3 is given in this question, so that is equal to 0.30 amps. So I2 is also equal to 0.30 amps. Now from here we can write down I1. I1 is equal to I2 plus I3 according to Kickoff First Law. So simply we can say I1, this will be equal to 0.60. Now what is value of I4? I4 also has to be equal to I1 because current entering the battery and leaving the battery is the same, or simply you can understand from here I2 is entering this junction and I3 is also entering this junction. So the I4 is leaving this junction, so this will be equal to I2 plus I3. So I4 is also equal to 0.60 amps. Now question is asking us to calculate resistance. So across this resistor, value of potential difference is given, that is equal to 2.4 volts. So this is 2.4 volts, and current passing through this one we have, this is 0.60. So simply we can write down R will be equal to V4, this will be divided by I4. So the V4 is 2.4 volts and I4 means current passing through this resistor, this is equal to 0.60 amps. So our final answer in this case will be equal to 4.0 ohms. That's what question was asking us to show that. So this is our final answer. This question has 2 marks, and the first mark is if you have got this value of I, and this is B mark. So you will get B mark if you have got I4 is equal to 0.60 amps, and the second mark is answer mark if you have got right value of resistance. So you will get 2 marks. For second part, we need to determine the EMF of the battery. And EMF of the battery, we can determine using different methods. We can use Kirchhoff's second law, or simply we can use Ohm's law. For this question, I will be using simply Ohm's law. In order to use Ohm's law, we need to calculate the total resistance of this circuit. So first of all, let's try to calculate what is the total resistance of these 2 resistors. The resistance of each resistor, this is equal to 4 ohms. We have just calculated in the previous part. So simply we can write down this is 4 ohms. And as these 2 resistors, they are connected in parallel. So the total resistance of these 2 resistors simply will be equal to the resistance resistance of one resistor divided by number of resistors. We have two resistors, so simply we can divide by 2. So the total resistance of these two resistors is simply equal to 2 ohms. Now this circuit we can redraw. So this is our battery. So we can draw, this is battery is here. We have one resistor, this is R1 resistor, and these two resistors we can simply replace with one resistor. Here we have resistor 4 that is connected here. So this is our new circuit. Resistance of this one R1, this is equal to 4 ohms. This resistance is also equal to 4 ohms. But this resistance of these two resistors, this is equal to 2 ohms. Now the total resistance, these three resistors, they are connected in series. So the total resistance is simply sum of these resistors. So our total for this circuit, that will be equal to 4 plus 4 plus 2. So simply this is equal to 10 ohms. So this is total resistance of the circuit. And current in the circuit we have already calculated. I1, this was equal to 0.60, and this is the current passing through the battery. Now we need to calculate EMF, so simply we can say EMF, this is equal to I total, means current passing through the battery, times the total resistance of the circuit. Total current passing through the battery is equal to 0.60 amps, and total resistance of the circuit, this is equal to 10 ohms. So simply this is equal to 6.0 volt, and this is EMF of this battery. This question has 2 marks, and the first mark is if you have calculated this total resistance, so this one will be the C mark, and the second mark is if you have got the right answer, and this one is answer. For part C, it is given to us the battery in B is replaced with another battery of the same EMF but with an internal resistance that is not negligible. It simply means that battery has internal resistance now, and we cannot ignore this internal resistance. So simply we can say this is small r. And this is all inside the battery. So this is our battery now. And this battery has internal resistance. So this is our battery, and this is internal resistance. This is resistance of the battery itself. So that's the reason we call this is internal resistance. Sometimes we also call this is source resistance. Now question is asking us, state and explain the change, if any, in the total power produced by the battery. Now we need to state and explain if there is any change in the total power produced by the battery. So in order to answer this question, first thing we need to consider is that, is the total resistance of the circuit, is it increasing or decreasing? We have already calculated total resistance of the circuit, that was equal to 10 ohms. But now you can see here we have another resistance that is connected in series. So it means the total resistance of the circuit is increasing. Total resistance of the circuit increase, so total current in the circuit means I total in the circuit, this will go down. So this will decrease. So these are 2 points we need to understand. First, total resistance of the circuit will increase and total current in the circuit will decrease. Next thing we need to understand the power. So we can say the P produced by the battery. So P by battery we can write down. So power produced by the battery, this will be equal to EMF of the battery, V square divided by R, and R is the total resistance. Now you see EMF of the battery is the same, but the total resistance has been increased. So it simply means that the power produced by the battery decreases. So these points simply we need to write down. So let me show you how you can write a proper answer. This is how you can write down a proper answer. So this question has 2 marks. You will get first mark, B mark, if you have written total resistance of the circuit increases. And you will get the second mark if you have written total current decreases. So the total power decreases. So this is how we can answer. Simply we can say battery will provide less energy per second to the circuit. So total power decreases. Total power produced by the battery will decrease because some of the energy, electrical energy produced by the battery will be converted into thermal energy inside battery due to its internal resistance. So that's the reason total power decreases. For the last part, it is given to us the resistors in the circuit of figure 5.1 are made from nichrome wire of uniform radius 240 micrometers. The length of this wire needed to make each resistor means one resistor is 0.67 meter. We need to calculate resistivity of nichrome. So simply we can start from here. R is equal to rho L by A. We need to calculate resistivity, so simply we can rearrange this one. So we can write down this is RA divided by L. A is the cross-sectional area of the wire. So simply we can write down this is cross-sectional area of the wire divided by L, the length of the wire. Now simply we need to plug in values. So resistance of each resistor we have already calculated. That was equal to 4.0 ohms. Now we simply need to multiply pi with radius of the wire. Radius of the wire is given, this is 240 micrometers. So this is 10 to negative 6. Square of this one, so we have to take square of the radius. We have to divide by L. L of each resistor means the length of wire for each resistor is given, that is 0.67 meters. Now simply we need to calculate and we can get value of resistivity for nichrome. In this case, our final answer will be 1.1 times 10 to negative 6 ohms meter, and this is our final answer. This question has 3 marks. The first mark is if you have written formula in this form, you will get C1 mark, and the second mark is if you have plugged in right values, and the last one is A mark. If you have got the right answer, you will get full marks. Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's class, we will discuss an important and tricky question on complex DC circuits. Why this question is important? Because this question is a great question to understand complex DC circuits. We will use a smart method to answer this kind of complex circuits. For this question, it is given to us that all the resistors are identical. Identical simply means that they have the same resistance, and all the emitters, they have negligible resistance. It simply means that emitters are ideal emitters and they have no resistance. Question is also telling us that reading on emitter 1, A1 is 0.6 amps, means reading on this emitter, this is given, this is equal to 0.6 amps. Question is asking us what are the readings on the other emitters, mean what is reading on A2, what is reading on A3, and what is reading on A4. This is what we need to find out. First of all, let's try to connect voltmeters across different branches. Let's say we have voltmeter V1 and we connect across this branch. So first across this branch. Let's say we have another voltmeter and the second voltmeter we connect across this branch here. And the third one, let's say we connect across the third branch and here. And the fourth one we connect across the fourth branch. Let's say this is voltmeter V4 and we connect across this branch. And this is the main idea you need to understand. If I look at V1, you can simply see here V1, and this is V2. You see, this is this point and this point, they are at the same potential because this wire is an ideal wire. So it means I'm finding the potential difference across this point and across this point. And for the second voltmeter, I'm finding the potential difference across this point and across this point. So the potential difference across these two branches is the same because this point is at the same potential as this one, and this point is a common point among these two voltmeters. So it means that V1 is equal to V2. So we can simply write down here V1 is equal to V2 because we are finding the potential difference between two same points for V1 and also V2. So we can say that V1 is equal to V2. Now let's look at this now. V3 now. If we look at this V2, this point and this point, they are at the same potential. And if we look at the second point, this point and this point, they're also at the same potential because one ideal wire between these 2 points. We can also connect like this. Let's say I connect this one to here, or I can extend this one to here. Result is the same. So it means that V2 is also equal to V3, and we can say it is also equal to V1. Now let's look at V4, reading on voltmeter 4 now. So this point and this point, they are at the same potential because there is an ideal wire between them. We can also connect like this. Let's say we connect to this point. And if we look at the second point for third voltmeter and fourth voltmeter is also the same. The first point is the same and the second point is also the same. It means that the reading on voltmeter 4 is also the same as reading on voltmeter 3. So here we can say that V1 is equal to V2 and this is equal to V3 and this is equal to V4. As the reading across each branch is the same, it simply means that all the branches are just connected in parallel. So this is just a parallel circuit. Let me redraw this one so you can get a clear picture of this circuit. I'm starting from this battery. So this is our battery. You can simply say this is a cell, and we have emitter A2 that is connected here. And after emitter A2 we have emitter A1, so we can connect emitter A1 here. So this is our emitter A1, and after emitter A1 we have two resistors, so we can connect two resistors here. So these are two resistors connected in series, so they are connected in series. Then we have the third branch, and for the third branch we have emitter A3 that is connected here, and we have one resistor that is connected in series with emitter. So we can redraw this one like this. And the last one we have fourth emitter, that one is A4, and this has three resistors connected in series, means 1, 2 and 3. So we can draw these three resistors in series. So here we can redraw these resistors here. So this is our circuit. So this is simple a parallel circuit. Now we need to find out the readings on A2, A3 and A4. Now let's say the resistance of each resistor, this is R, so simply we can write down here each resistor has the same resistance because they are identical resistors. Let's say current coming from the battery and passing through emitter 2, let's say that current is I2, and current passing through emitter 1 and through these two resistors, let's say that current is I1, and the reading of I1 is given as it is given here, that is equal to 0.6 amps. 0.6 amps. And let's say current passing through emitter 3, this is I3, and current passing through emitter 4, let's say this is I4, and also the same current is passing through these three resistors. First of all, look at V1, and V1 is equal to V3. So V1, if we look at V1, this is equal to 0.6, means current passing through this branch and its resistance, and let's say its resistance is 2R because we have said resistance of each resistor is R and these two resistors are connected in series, so the total resistance of this branch that is equal to 2R. And for V3 we can simply say this is I3. We don't know what is value of I3, but we know the resistance of this branch that is equal to R. Now from here we can cancel R because this is common, and we can find out I3 from here, and that is 2 times of I1, so simply is equal to 1.2 amps. So this is reading on emitter 3 we can find out. Now let's try to find out reading on emitter 4. Again we will compare with V1. V1 is also equal to V4, so we can again write down V1 is equal to V4, and V1 is equal to 0.6 times the resistance of this branch, that is equal to 2R. And current passing through emitter 4, this is I4, and the total resistance of this branch, this is equal to 3R. R. Now R is common, we can simply cancel. So I4 is simply equal to 1.2 divided by 3. So this is equal to 0.4 amps. So this is reading of I4. Now if we need to find out I2, so I2 simply equal to I1 plus I3 plus I4. So if we add all of them together, our final answer will be 2.2 amps. Now you can see I2 is 2.2 amps. So this is the right answer. D is the answer. And I3 is 1.2. So this is 1.2. I4 is 0.4. So this is 0.4. So our answer for this question is D.